Good morning, my dear students. Welcome to the discussion on the subject engineering graphics. Under engineering graphics, we are going to discuss a topic on development of surfaces. Under development of surfaces, we are going to solve a problem on radial line method. This is the second solved problem we are discussing under radial line method under the topic of development of surfaces. Now we will enter into the problem. The given problem is a square pyramid of base 40 mm side and axis 60 mm long has its base on the HP and all the edges of the base equally inclined to the VP. It is cut by a section plane perpendicular to the VP, inclined at 60 degrees to the HP and bisecting the axis. Draw the development of the lateral surface of the truncated pyramid. This is the square pyramid and it is resting on its base on HP such that all the edges of the base are equally inclined to the VP. That is, the edges say AB, BC, CD and DA are equally inclined to the VP. That means all these sides of the base are making an angle 45 degrees to the XY line in the top view. The square pyramid is cut by a section plane which is perpendicular to the VP and inclined at 60 degrees to the HP and bisecting the axis. That is, the square pyramid is cut by a section plane. With that, the top portion of the square pyramid is removed and bottom portion of the square pyramid is retained. Then we are going to develop the lateral surface of the bottom portion of the square pyramid. Then we will move towards writing the data. Here, the name of the object to be developed is lateral surface of the truncated square pyramid. The base side length of the square pyramid is 40 mm, axis height is 60 mm. The given condition is the square pyramid is resting on its base on HP and all base edges are making equal inclination to the VP. That is, the base sides say AB, BC, CD and DA are going to make an angle of 45 degrees to the vertical plane. Then related to the section plane is perpendicular to the VP and inclined at 60 degrees to the HP and bisecting the axis. Here, our objective is to develop the lateral surface of the truncated square pyramid. For that, first we need to draw the true shape of the base of a square pyramid. The first step in the projection of solids is to draw the true shape of the base. Here, the square pyramid is resting on its base on HP such that all the base edges are equally inclined to the VP. So, the true shape of the base is visible in the top view. Here, in the top view, you are able to see the true shape of the base, that is square, with all the sides are making an angle of 45 degrees to the XY line. So, draw top view of the square pyramid. Then draw XY line. Here, in the case of top view, we are able to see the true shape of the base of a square pyramid, that is square. In addition to that, in the problem it is mentioned that all base edges are equally inclined to the VP. So, draw 45 degrees inclined line to the XY line. Then complete the construction of square so that one of the base side here aligned to the inclined line. Here the base side length of the square pyramid is 40 mm. Then name the corners of the base of a square pyramid in top view. Then locate the apex point in top view. Then draw images of the slant lines of a square pyramid in top view, say OA, OB, OC, OD. Then we will draw with the given axis height front view of a square pyramid. Here axis height is 60 mm. With this brief explanation about drawing top view as well as front view of a square pyramid, we will enter into the detailed construction of the development of the lateral surface of the truncated square pyramid. The following steps are considered for the detailed development of the lateral surface of the truncated square pyramid. The first step is to draw top view and front view of the pyramid. Second step, to draw a section plane line with the given condition. Third step, to draw development of the lateral surface of the truncated pyramid. With this, we will enter into the detailed construction of the development of the lateral surface of the truncated square pyramid.
Here, the square pyramid is resting on its base and HP such that all the sides of the base are equally inclined to the VP. In this position, we need to draw top view as well as front view of the square pyramid. For drawing top view as well as front view of the square pyramid, as a first step, we need to draw XY line. After drawing the XY line, we will draw top view of the square pyramid. Here, the square pyramid is resting on its base and HP such that all the sides of the base are equally inclined to the VP. So, draw 45 degrees inclination line to the XY line. Then align one of the base side of a square pyramid along this inclined line. Here the base side length of the square pyramid is 40 mm. Then construct the square. Name the corners of a base of a square pyramid. Here, the sides of the base of a square pyramid, say AB, BC, CD and DE are making equal inclination to the vertical plane. That is, all the sides of the base of a square pyramid are making an angle of 45 degrees to the vertical plane. Then, locate the center of the base of a square pyramid in top view. For that, draw two diagonals. Here, O is the center of the base of a square pyramid and also it is the image of the apex in top view. Here, AB, BC, CD and DA are the base edges and OA, OB, OC and OD are the face edges of a square pyramid in top view. With this we completed drawing the top view of a square pyramid. Then we'll move towards drawing the front view of a square pyramid. For that, draw projectors through the points say A, B, C, D and O towards the vertical plane. Under this, first we will draw projector through O towards the vertical plane. Here O is the image of the axis as well as apex point in top view. Here the axis height of the pyramid is given in the problem as 60 mm. Then name this point as O dash. Then draw projectors through A as well as C onto the XY line. And name these points as A dash, this is C dash, D dash and B dash. Then join the points say O dash, A dash, A dash, C dash, C dash and O dash with straight line segments. In the case of front view, the face edges images say O dash A dash, O dash B dash and O dash C dash are continuous, and base edges say A dash B dash to C dash are also continuous. With this we completed drawing top view as well as front view of the square pyramid. Then we'll move towards drawing the section plane line. In the problem it is mentioned that the section plane is inclined with an angle of 60 degrees to the HP and perpendicular to the VP and passing through the midpoint of the axis. So first locate the midpoint of the axis. Here total height of the axis is 60 mm. So the midpoint of the axis is at a distance 30 mm from the base or 30 mm from the apex in the front view. The section plane is inclined with an angle of 60 degrees to the HP and passing through the midpoint of the axis. So draw section plane line. With this section plane, we are cutting the square pyramid. With that, this portion of the material is not used for the development. Only this portion of the material is to be used for the development. So, dark the region which is to be used for development. The part P portion of the square pyramid is to be developed. Now we will locate the intersection points of the section plane with base edges as well as face edges of the square pyramid. Here 1 dash is the intersection point of section plane as well as base edge say A dash, B dash, and 2 dash is the intersection point of section plane as well as face edge say O dash, B dash. 3 dash is the intersection point of section plane as well as face edge O dash C dash. 4 dash is the intersection point of section plane with O dash D dash face edge. 5 dash is the intersection point of section plane as well as base edge A dash D dash. As I said earlier, 1 dash is the intersection point of section plane with A dash, B dash, base edge, and 5 dash is the intersection point of A dash, D dash, base edge with section plane. So 1 dash as well as 5 dash images to be transferred onto the top view of a square pyramid. For that, draw projector through 1 dash as well as 5 dash towards the top view of a square pyramid. One is the intersection point on AB base edge with section plane, and 5 is the intersection point on AD base edge with section plane. Then dark 5-1, 1B, BC, CD and D5 points. If you observe it, the image of O dash A dash slant line in top view say OA is parallel to XY line, and O dash C dash slant line image in top view say OC is parallel to XY line. So O dash A dash and O dash C dash are called as true length of the slant heights, whereas O dash B dash, O dash D dash image in top view are not parallel to the XY line. So they are not called true length of the slant heights. In order to convert O dash D dash and O dash B dash as true length of slant heights, we will draw horizontal through 2 dash as well as 4 dash towards this true length of the slant height. and name this point as 2 1 dash and 4 1 dash. With O dash C dash or O dash A dash as a radius, that is true length of slant height as a radius, O as a center, draw an arc for the development of lateral surface of square pyramid. The method which we are using is radial line method. Then locate a point A on the arc with AB as radius, that is base side length of a square pyramid as a radius, A as a center, draw an arc on already drawn arc, then name this point as B with B as a center, draw an arc, name this point as C, C as a center, draw an arc, then name this point as D with the same radius, draw an arc, then name this point as A. Join A to B, B to C, C to D, D to A points with straight line segments, and O to A, O to B, O to C, O to D and O to A points also with straight line segments. Here 1 is a point on AB base side and 5 is a point on AD base side of a square pyramid. Then take A1 as a radius, A as a center, draw an arc on AB base side in the development. Similarly, A5 also with the same radius. So A as a center, A5 as a radius, draw an arc on the AD base side in the development. Then name this point as 1 and this point as 5. As we consider O dash C dash as the true length of the slant height, then we'll consider the section plane points along this line only. Then take O dash 2 1 dash as a radius. As you know that 2 dash is the intersection point of section plane with O dash B dash face edge. So with O as a center, O dash 2 1 dash as a radius, draw an arc on OB slant edge. Name this point as 2. Similarly, O dash 4 1 dash also with the same radius, but 4 dash is the intersection point of section plane as well as O dash D dash face edge. So with the same radius, that is O dash 4 1 dash as a radius, draw an arc on OD slant edge in the development. Name this point as 4. Then O dash 3 dash as a radius. As you know that 3 dash is a intersection point of section plane with OC face edge. Then name this point as 3. Then join the points say 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to D, D to C, C to B, B to 1 with straight line segments, that's to with H pencil. That means we need to draw thick lines. Then Draw the part of the face edges of a square pyramid, say B2, C3 and D4. This is the required development of the truncated square pyramid. Now we'll see the pencil usage details. The portion which is highlighted here with blue color lines are with H pencil, whereas the remaining lines are with 3H pencil. The dimensioning is with 2H pencil, and in the case of development, the blue color thick lines are with H pencil, and these pencil marks are with 3H pencil, and this dimensioning is with 2H pencil. Related to the dimensioning details, the base side length of the square pyramid is 40 mm, axis height is 60 mm, and the section plane is passing through the midpoint of the axis. That means the midpoint of the axis is at a distance 30 mm from the base or from the apex. That means all the dimensions are in millimeters. Make a note, for drawing the arc in the development, we have taken true length of the slant height. The true length of the slant height is 1, whose image in the top view is parallel to the xy line. Here O dash A dash as well as O dash C dash images are parallel to the xy line in the top view. So they are called as true length of the slant heights. This is the required development of the lateral surface of a truncated square pyramid by using radial line method.
If you have any queries or doubts related to the present solved problem, you can mention it under comment section of this video. I'm happy to answer it as quickly as possible. For more videos on engineering graphics, visit the links provided under description of this video. Keep learning on knowledge sharing. Stay blessed. Thank you.